Hey all. So there's a couple questions that we didn't have time to go over in class, so I wanted to go over them in here. And this is not Cami, this is the wrong one. There we go, that's the right one. So I'm just going to go over real quick how to do these problems. They're really not that hard, they're just kind of confusing and how you plug stuff in. So for these two, these are on 3.1, the first section that deals with imaginary numbers. Okay, and so it's saying h naught, that's how you say that, h0, it's called h naught. It's the starting point, so the initial height. And then the negative 16 squared, that's just, it has to do with physics. It's part of the physics equation, so when something's falling, it has to do with acceleration and gravity and all that stuff. You don't need to know all that, just how to use the equation, okay? So that's always there, that 16t squared, t stands for time. So if they ask for time, that's the thing we're talking about. And then we have this ht here. That ht, that stands for the height at any specific time. So if you want the height at 3 seconds, that would be h3. If you want the height at 6 seconds, it'd be h6. Okay, that's pretty much it. Okay, so now let's go to this first problem, and I'm just going to show you how to plug it in, and then you can solve it, because I don't want to spend a lot of time on these. Okay, a carpenter dropped a hammer from a rooftop 48 feet above ground. How long did it take for the hammer to hit the ground? All right, so what we have here is the h naught. That's the starting point, so where the hammer started. So this hammer started at 48, right? Started at 48 feet, all right? And then we still have this negative minus 16t squared. That's still there. It doesn't change. Whenever you're doing one of these equations, you have that negative 16t squared. Okay, and this equals, we want to know when the hammer hits the ground. Well, what's the height of the ground? The height of the ground is 0. There's our equation. Now we're going to solve it, and it's pretty easy. Well, you know what? I'll solve this one so you can see how it works. So what I'm going to do is I am going to take this piece and move it to the other side. So we get 48 equals 16t squared. Okay? Then I'm going to divide both sides by 16. Divide both sides by 16. I think it's 3. 16 times 3. 3 times 6 is 18. Yep, 48. So we get 3 equals t squared. Okay? So then the last step is, well, what's t? We take the square root of both sides. T equals the square root of 3. So that's how long in seconds it would take. It would be the square root of 3. You can leave it there. I don't need you to do the decimals. I think it's like 1.3, 1.4 or something. I don't know. I don't need the actual decimal. I just, radical 3. There you go. Okay, so then if I look at number 11, it's the same deal. I'm not going to solve this one. I'm just going to set it up for you. So an acorn fell from a height of 20 feet high. Okay, so that's the initial or starting height. So that's going to be the h naught is going to be 20. So I'm going to write h naught. Landed on a branch 7 feet high. So that's the height in question. So the last time it was the ground, which was 0. This time it is the 7. So that's going to be my ht. How long did it take for the acorn to fall? I just plug it in and solve it. So ht is going to be 7. So we have 7 equals h naught, which we said was 20. And then we always have that minus 16t squared. And then you go ahead and solve that. Stopping there. All right, let's go to the next problem. All right, so these guys, I'm actually going to pause this for a sec.